Hi, sir.
Hello, Amy. How are you doing?
I'm good, thank you. How are you?
Very good.
Ready?
So let's
Yeah.
continue. Okay. So the other
Okay.
example is about continuous data, as I was talking about. So we'll say, what happens when you have a continuous data to work with? So let me enlarge this a bit so that it becomes easier for you to visualize.
Mhm.
Okay. So we'll actually calculate the similar values which we did last time, but now the data is continuous. Continuous means uh, we have uh, running, like if you measure the height of students in a class, you get my point. So the height could be 170, 171, 172, 173, something like this in
Oh,
centimeters, 172.5. I mean, there are a lot of values which are kind of considered to
right.
be
Yeah.
continuous. Now, if I give you that kind of data to work with, how do we find medians and quartiles? That is what we need to understand. So first thing is, when you have the data, arrange them in a particular order. Then group them into classes, right? So those are the steps which you need to do. So let me just write these here. First is arrange in increasing order. Right. And second step is divide into classes. We normally use the word interval. So depending on how much data is there, you can decide the length of the interval, right? So in this particular case, it is very similar to the example which we took. And here also, can you
Mhm.
please read this question here?
Yeah. The table shows length of Atlantic salmon caught by Amy.
Yes.
Great. I love to be a
Sure.
fisherman.
So
Right.
what I did was we just grouped them into different groups. Most of the salmon, when we had looked at the data, the minimum value was close to 60 and the maximum was close to 75. So that becomes our total range. Now we divide this range into intervals of 2.5. So to be very precise, so we have an interval of 2.5 here. So 60 to 62.5, 62.5 to 65, 65 to 67.5, and so on. So I've just not used inequality in this particular case, but I'm saying that my interval is from 60 to 62.5, correct? Now here, I will discuss with you two ambiguities which are defined, which are seen in many books and which are not clear. So what I've done is
Mm.
I'm starting with an ambiguity. I'm just not saying whether my values include 60 or exclude 60. I'm not saying whether
Yeah.
my value includes 62.5 or exclude 62.5 in the very first interval 60 to 62.5. So you have to
Mm.
understand. So what normally happens is that when we have an interval like this, then if let us say this length of the fish is 62.5, then we'll consider it here, not there. You understand? That means we will treat this interval in this fashion. That is, interval 60 to 62.5 literally means that the length here is greater than equal to 60, but less than 62.5. Is that clear to you? You
How do you
see,
know that though?
no, this is how I have defined. When I collected my data, if the fish length was 62.5, I've made a count here,
Oh,
not there.
okay. Yeah.
You know, now, so you have to be very clear whether this is what you're going to follow, or sometimes we do this also. We say this, but we say, well, 62.5 is actually included here.
Yeah.
So either
Yeah.
one.
So,
So but or means you should be sure about it before you start answering the question. You get my point?
oh, right. Okay. Yeah.
If you are given
So,
the values in the interval form, there is no ambiguity. You're clear about it. Whether you're working with this kind
yeah.
of data or that kind of data. You understand?
But just a quick thing. So if they gave it like the way you've given it here, but they
Yes.
haven't specified what's included or what's not included, then how do I know like do I just make up saying at the end of each one, we're saying, so then on the first block, we're going to say the 62 is not included, second one
Yeah.
is included, or
Correct. So
or like, do you just make up the rule?
In that case, you have to decide whether you follow this or that. Therefore, it means again what? It means check with your teacher. Because actually, the teacher is deciding for you, not you. Your teacher is deciding for you. Check with your teacher.
I don't like this. I would. The reason I chose maths was because so there's only one answer. There's no discussion. It's like no debate, no analysis. I don't like what's happening.
Not in statistics. Here, a lot of ambiguities. Again, they take help of the word estimate.
Oh.
And approximate. It is all approximate and estimate. Okay, so it doesn't matter whether you include or don't include. It doesn't matter much.
Yeah, no. It's just that there is still, at the end of the day, even though it's an estimate, there is only one answer in the mark scheme.
Correct.
So you have to follow your teacher's method or whatever it is.
Perfect. That is why before even starting to teach you, I'm telling you the boundaries. That is very important, right? Because these are different boundaries in different countries, and I don't know exactly what your teacher is going to follow. Your teacher is correct from my side, so I'm just giving you an option. Check with your teacher which is the correct way and follow that. Is that clear to you? Okay, now great. Yeah. So before we begin with this, you should be clear. If I write 60 to 62.5, again 62.5 to 65, what does it mean? 62.5 is included or not included in first data, right? Now, I've seen some very beautiful solutions and some excellent books. What they do is, if they're rounding the figure to one decimal place, they will make a group, not 60 to 62.5, but they'll change this number to 62.55. So in that case, there won't be any data whose length will be 62.55. Do you get my point? And this also they will write 62.55. You understand now? So they will use two decimal places if the data is given to one decimal place. So that actually removes the ambiguity. Let us say, you get my point.
I get it, but then I kind of lost it because then the same values are still there, but I know it doesn't apply anymore because the rest of the data is in one decimal place.
Let us say your data is like this: fish length 61, 62.5, 63, 64.2. Let us say this is your data.
Yeah.
I am using an interval which is 62.55, another decimal place. There is no data to second decimal place. So now I'm very clear. There is nothing which is 62.55, right? That is how we make this continuous, right? To make it continuous, we have to repeat it. Otherwise, there'll be a break.
All right. Okay. Yeah.
You get my point?
It's clear.
If I use 62.55 at both the places, my data is absolutely clear. It is up to one decimal place. So there won't be any number which will be 62.55. It will be either less or greater.
Oh, so if you were going to say where does 62.5 lie, it has to be in the first block because you ended it with the 62.55 and it can't be in the next one.
Next one.
Oh.
I will use that in the first block.
Get it.
You get the idea. And I will make a group. I will make a group which will where I will write 62.55. I will go to two decimal places if the data includes one decimal place, correct?
Oh, okay. Yeah. So if the data all had second 2 dp, then if it had like this, you would make the next one to 3 dp like that.
Yes, yes. Now, why did I take one decimal place? Because I rounded all values to 1 centimeter. So I do not have any decimal place in my data. You get my point? So in my examples, I'm taking length of the fish round to centimeter. Therefore, I do not have any decimal value. You know my point. So that is what I normally assume. And therefore, I've taken a length which is 62.5 and I will not have any ambiguity. You get the idea?
Right. Yeah.
Okay. But remember, we have rounded the data. Actual length of that will appear, right? The length could have been 62.5, but we rounded to 63.
Right. Okay. Yeah.
And then we made our table. Think like this. But anyway, two very important things to consider is whenever you work with such groups, you need to understand whether you are following this nomenclature or that nomenclature. In case you get a
But
data.
does that still apply? Does that still need to apply if we just put 62.55?
No, then not. Because
Yeah, okay.
the data is accurate to one decimal place, you have used two decimal places,
Right.
then it will never apply. Correct. Now,
So can I just do it like that then?
yes, you can. And then
Okay.
round your answers to required value. So they'll say round
Okay.
your answer to one decimal place, round your answer to one decimal place. You will get accurate results.
Okay. Yeah.
You have to be careful on
I'll
this.
do that.
Again, check with your teacher. What is the best? Because I don't want you to waste your time in things which are not very critical, right? So rounding and working with more decimal place means extra time. We don't have luxury of time in test paper. So you have to clear all these points before the test. Okay.
Right.
Perfect. I'd like you to read these points. Can you please read this? What have I written here?
Describe cumulative frequency plot.
Ogive. A
Okay.
cumulative frequency plot is given many different names. Let me just explore this part also. It is called ogive.
All right.
We say cumulative frequency plot, cumulative frequency polygon, cumulative frequency diagram, cumulative frequency curve. There are so many terms which are used with this cumulative frequency. The idea here is whenever you make this plot increasing order, it is in the S shape. So sometimes we also say S-shaped graph. Now, it is strictly speaking a polygon. The actual name should have been cumulative frequency polygon, because when we have this interval, then all the elements, now let's look into the data and then I'll get back into this discussion of the name itself. Okay.
Okay.
So this data given to us is that in the first interval, we have got 2, the second 8, and likewise, as you can see. Now, this number within that interval is called the frequency. Now, cumulative frequency is the running total of your frequency. That is cumulative, right? Add on. Is that okay? So that is the meaning of cumulative frequency. So what we need to do basically is that we are saying how many are below 62.5. That is what we are trying to say, correct? So that we say, note, default method to plot cumulative frequency diagram is less than method, less than. So we're saying how many are less than 62.5? There are 2 less than 62.5. This is what we are trying to say, cumulative frequency. Is that clear?
Yeah.
How many are less than 65? Well, 2 and 8.
10.
So you keep on adding. So what method we are applying here is, which we call the default method, is we want to plot cumulative frequency diagram where the method is less than method. Whenever you're applying less than method, the key value you look at is the upper bound. Means what is less than 65? The upper bound of the interval. You get the idea?
Yeah.
Very important to understand.
It's clear.
There is another method also, which could be there in the test. They may say, draw the cumulative frequency diagram using more than method. You get my point? Then in that case, how many are above 660? All of them.
Yeah.
It will be reverse. That graph will be broken down. So one point.
Yeah.
Read your question carefully, because in GCSE they do.
Yeah. So if it says less than method, you use the upper bound. If it says more than method, you use the lower bound. And then the graph would invert the other way.
Default is less than, you get an S-shaped increasing curve. Okay. So, and it has a different name, Ogive also. Many students will use this in different parts of the world. Then draw the cumulative frequency diagram. That's what we are going to do. From the diagram, we are going to estimate the median length of fish, estimate lower and upper quartile, and we'll find the interquartile range and 90th percentile, and we do all those calculations. Perfect. So let's begin with the cumulative frequency graph. I will say a polynomial. Well, good. I have mentioned all the names here. So describe ogive or cumulative frequency polygon diagram, graph, or S-curve. These are alternate names which are being used in different places. Okay. We will follow the method, the name polygon. Polygon means
Okay.
it is a set of lines. You understand? Not strictly, because polygon could be closed, open, whatever, but it is definitely not a curve. When we do 60 to 65, let us say if we get these data elements, then I'm going to join them with a straight line, not with a curved line. You get my point? My
Oh, okay.
frequency diagram will be a straight line, not a curved line. Reason is,
Oh,
yes, let's understand the reason why it is not a curved line. It is a straight line in between the two intervals, because when I say there are two elements in between 60 to 62.5, where are those two elements? They are in between them, correct? We are
yeah,
saying there are 15 elements between 65 and 67.5. We don't know what their actual values is, right? Where are they?
yeah.
Let us say this is my group, which is 65 to 67.5. Where are my data elements? So what I assume is that
Somewhere on the line.
they are linearly distributed uniformly between this.
Oh, because if you drew a curve, that means you accurately know where each one of those points are, which you
Yes,
don't
yes,
know.
yes.
So you have to assume
Then you
that
can
they're
draw
all
a curve,
equal.
but we don't know.
Oh, yeah. Okay.
You
I
get the
didn't think
point,
about it
right?
like that. Now it's really clear. Yeah.
Yes, yes, yes. So now, Amy, you collected these fish, found their lengths, but you forgot. Once you put them on the table, then the fish doesn't exist.
Wow, that was a waste of time.
Okay.
Yeah. Well,
So now, getting back to the topic, cumulative means increasing by successive addition. This is what word means. Running total. That is what it means. Plot upper class boundary with cumulative frequency. Connect points with a straight line. Lines signify linear distribution in the group. This is the most important sentence. You understand? When
okay.
I'm drawing
Okay.
the straight line, it will signify linear distribution in the group. So all 15 are actually linearly distributed between 65 and 67.5. If I say there's only one element, I'll assume it to be in the center. The value of that element will
Right.
average of 60 and 62.5. It'll be 61.25. You get my
Yeah.
point?
Yeah.
So I can now assign a value very accurately by the assumption that they are linearly distributed in the group. So
Yeah.
I can actually give you two decimal place answer here using this distribution to be linear. And then
Right.
I will round it to the required answer. This is what I'm going to do. You see how accurately we can work with the
Um,
running totals?
yeah.
Got
Yeah.
it? So
Yeah.
now let's look into this. So basically, when we have to, let's consider the points. So first is, we'll make a cumulative frequency chart that is increasing total, right? So 2 and 2 plus 8 is 10, 8, 10 plus 15, 25. So I made a cumulative chart, and here we get the value of n, which is 80. So the total number of fish in this case were 80, and they are distributed in these intervals as shown in the diagram. So how many are less than 62.5? There are two which are less than 62.5. How many are less than 70? 58 are less than 70. That is what we are trying to say here. And how many are less than 75? 80 are less than 75. That is what we are trying to say when we say this cumulative table, this case. Is that clear to you?
Yeah. Yeah.
Now, another thing, when we have to plot this diagram, we could do a couple of things. And one of them is that we could consider all the two to be at the center point. We could do that, right?
Okay.
Yeah. So we could do that. But what we will actually do is, when we are going to plot we, as you had discussed earlier, we are going to take the upper bound. Do you see? Because we are doing the increasing, right? Less than graph,
Yeah.
less than method. So we are going to use the upper bound. Is that clear? So we are saying that how many are less than 62.5? There are two less than 62.5, and therefore I get a coordinate point 62.52.
Oh, because you took the cumulative frequency. Oh, and then you get a
Yeah.
coordinate point, right?
Yes.
Yeah.
Upper bound 62.5, cumulative frequency 2. Upper bound 65, cumulative frequency 10. I get the next coordinate point. I have to draw the cumulative frequency polygon or diagram, whatever, right? So these are the 6 set of points from the 6 intervals. Last one being at 75, I got 80. So that is my last
75.
80.
Yeah.
Right?
Could I ask 2 questions?
Sure.
First question is, you know, when you draw the polygon,
yes.
You know, where you don't like put it to the origin because it doesn't start at 0. Where do you know where to put the point? Like, is it the lower bound?
Good question. Oh. Good question. Very good. Okay. So what we do here is like this. How many are less than 60? So we'll go for less than 60. How many? 0. So when 60 becomes, so that point is 60, 0.
Yeah.
You get the origin now? Starting point? Starting point is 60, 0.
Oh.
How many are less than 60? 0.
Oh, the way you did that. Yeah. Oh, right. That makes sense. I didn't understand why it was, because the cumulative frequency is 0, it has to be on the axis, and then it's at 60 because it has to, there's nothing less than 60.
Nothing less than 60. So, very important to understand, Amy. Note, can you please read this note?
Default method to plot the cumulative frequency diagram, or like polygon. The less than method is where the upper bound is taken to plot the graph.
Clear. So all these coordinate points include the upper bound and the cumulative frequency, and that is the graph which we are going to draw. We'll take cumulative frequency on the y-axis and the upper bound values on the x-axis, and then we are going to draw this. And we are saying, when we say 80, that means everything less than 75 is 80. Okay?
Yeah.
Now let's go to how do we actually do it. Now here's your graph. Now you will notice in this graph that I have taken a point 0 for 60, because what is less than 60? What is less than 60 is nothing, and that becomes our starting point. So it is very important to consider the starting point.
Oh, right. Okay.
Is that clear to you? So we did calculate the other points, with 6 of them earlier. Now coming back to your question.
I was thinking,
read.
How about less than 60? So that's weird. I didn't know you were going to have that on the next slide. Yeah, because I was just thinking that if we have all the other points, won't it just be a line floating in the middle of the graph? So I was wondering, where is that like start point? But then, when you explained it being 60, 0, it makes sense.
60, 0. That has to be your starting point. If you miss this point, you have missed at least 10% pass.
Yeah.
Very critical. And that is your last point. Is that clear to you? Which shows n value of 80 in this particular case. Now, this value of 80 is very critical. Since from this value, we are going to calculate median, Q1, Q3, and everything. Is that clear to you? 80 is our n value.
Right. Okay.
From where we'll do all the calculations. Now, in this case, where we are considering the cumulative data, in that case, we'll take n as 80. Now, let's see how to calculate the percentiles using, we have already drawn the cumulative graph. I hope, is that clear to you? This Ogive or the cumulative graph is clear to you, right? So we just plotted these points on the graph and then connected them with straight lines. All are straight lines, right? No curves.
Linear distribution.
That they are linearly distributed. All these 33 elements are linearly distributed in the interval 67.5 and 70.
Right.
Okay.
Yeah.
Now, let's go to percentile definition and see how do we work with percentile and ogive or cumulative frequency polygon. Okay, so now we'll discuss cumulative frequency plot, quartiles, and percentile, plot ogive or cumulative frequency polygon, which we have already done. You can see right there from the given data in the table. Now we'll estimate the median, lower and upper quartiles, interquartiles, and 90th percentile. Now clearly, we have the value n equals to 80. To find the median, we have to find the center value. So we'll do 50% of 80. So 80 times 0.5 is 40. So we're looking for where is 40 in the graph, correct?
Yeah.
So you can draw a value. The horizontal line, which is here, 40, correct? So you go like this to the graph and then down there, and you find the median value can be read from the graph as 68.6. So you get your median from the cumulative frequency. Is that part clear to you?
Yeah.
Correct.
I did
quartile,
something.
25th percentile. So multiply 80 by 0.25, you get the value 20. So this is your 20, right? And you go and then check the value 20, and you get Q1, which is 66.6 in this particular case. So you get the value of Q1.
Could I just ask something quickly? If you had to find the percentiles, and then you've got the table, but they haven't given a graph or anything, and you haven't graphed, is there a way of calculating without the graph?
Yes, there is.
Okay.
So I'll take that tomorrow in the next lesson.
Okay.
Without the ogive, how do we calculate? And there is, that is the place where linear distribution will be handy.
Oh, right. Okay. Yeah.
I'll give you an hint.
Back to the graph.
Right?
Oh.
So calculate from the table. You are saying that 60 is the value which you are looking for to find the upper. This should not be upper. If this is, upper quartile means Q3, right? Okay, Q3. So upper quartile is 75th percentile, and you're looking for a value which is 60. Now in your graph, where will 60 come? 60 will come here, right?
Yeah, because the one before is 58, right?
Which is within the from 70 to 72.5, correct? There are 19 elements in this interval from 70 to 72.5, correct? Already before this is 58, correct? Where is 58, 59, 60. So out of 19 elements, 60 is actually very close to 70. Therefore, my estimate will be 70.2. Not 72.5. My estimate will be closer to 70, and I'll estimate this as 70.2. You get the idea?
All right.
There are 20 elements. I'll say 20 elements. Each is like, I can distribute them now linearly between 70 and 72.5. And this is very close to 70. So my estimate is 70.2. Do you see how far?
All right. Okay. Yeah.
Because of my linear distribution. Similarly, you should be in a position to reason out for the 20th value. 20th will means within this interval. How? From 10 to 25, right? So 10, 11, 12, 13, 14, 20 will come close to 25, right? That means closer to 7.5. And
then you'd say
6.6 is a reasonable estimate. From
okay.
That is how you're going to do it. But of course,
makes sense.
Graph makes it very simple. Once you make the lines
and accurate.
Correct? So similarly, Q3 will be 75th percentile. Once you do Q3, you get your value. And there, sorry, this is Q3, which is, let me write down. Okay. So Q3 is 75th percentile. You get a value, which is 60 for us. So for 60,
$70.2.
Here it is. We are doing now Q3, right? Q3 is 70.2, right? Yes, 60. So on this scale, 60 is here. And then when you go to 60, you can read the value. Sorry, 60 is here. Sorry. That is 90 percentile, 60. I wrote this cute. And the value is 70.2 on the graph.
Yeah.
And that is how you can easily read. Now you found how do you now know how do we find Q1, Q2, and Q3 from the graph. Interquartile range is difference between Q3 and Q1. Okay. And so it is 70.2 minus 66.6, and we're just 3.6 in this particular case, right? That is interquartile range.
Yeah.
90th percentile means I'll multiply 80 by 0.9, get 72, and at 72, I've drawn a horizontal line which ends up on the axis at a point which reaches 71.8. So 90th percentile is 71.8 for me. Is that clear to you?
Yeah.
So that is how you could use the cumulative frequency graph to calculate all the quartiles and all the percentiles. Do you understand?
It's so easy when you know how to actually do it, isn't it?
So can you summarize this part, please?
Yeah. So like you said, when we're beginning with this topic, you just first think that it is an estimate, whatever you're calculating. There are a few differentiations depending on where you are in different countries and stuff. But at the end of the day, the method is the same. It's just here and there will be a few tweaks. But yeah, so when talking about this table, we use the less than method. This is the standard kind of default method, but don't just think this is the method and end of. It's always like read the question. So usually you see this S kind of shape. We don't, so I just explain why we don't say curve is because the points are evenly or linearly distributed within each interval. And so when you plot the points of those intervals, you have to draw a straight line between them because you don't know exactly what the values are in order to draw that curve. So always draw straight lines between the intervals. And so that's where and then so when you use the less than method, you use the upper bound, and then when you work out the cumulative frequency, because you use the upper bound and then say what's less than that, how many is less than that. So then you just start adding up the values, and then you would, by the last interval, you will have the number of things in that data set all below that last upper bound that you've got. So yeah, that's critical. And then when we came to this kind of question is when it's given in this kind of format, not with the inequalities, how do you know whether that upper bound is included or is it not included and things like that. So to prevent you from getting all confused from all of this, if it's given all the data in to one decimal place, then if you make that last value to 2 decimal place and make it 62.55, then none of the value in the data set would have that. So you kind of eliminate that, like you said, ambiguity between whether it's included or not. So yeah, that's a crucial thing. Then the next thing we learned was just about how to draw the graph and where to start. The starting point would be whatever the first interval is, that lower bound, is there anything less than that value? The answer would be no, because then it wouldn't have started from that. So then the point that you plot is simply that lower bound and then 0.0, because there is the cumulative frequency for that is 0 because there's nothing less than that. So remember, you join it up, because if you don't do that and you just have a line flowing in the middle of the graph, then it's all wrong. But then make sure the cumulative frequency is on the y-axis and then the upper bounds are on the x-axis. Labeling your axes is also important, because it looks like it's small marks, but they all add up and then you just lose a whole grade and you just be like, whoa. So yeah, let's remember that. And then the n equals 80. So the total number is critical because that's the value we're going to be using to find all the percentiles. And when it says your lower quartile, it's quite simple, really. After you find your 25%, like we just learned about using the formula, when you find the term, all you do is go to your graph, draw a nice straight line, accurate line, and then go down and then read off the value and write it down.
Yes. Now, Amy, let me summarize here. One more thing I will add is sometimes we use the value of capital N, which will be n plus 1. Now, but sometimes we do that. You may have to check with your teacher on this point also, that in case we are doing cumulative graph, do we take n as n plus 1 or not? Is that clear? Should I be taking this as 80 or 81? Because median is the middle value. Do you understand? So 50th, if there are 80 elements, actually speaking, 40th element is not the middle value. The middle value is between 40 and 41st element. So exactly speaking, but because it is a graph which is estimated, and for easier calculations, we use the even number, 80 in this case. It gives us a better values, and on the graph, easier to plot. Correct? So 80 makes more sense here. If I would have changed this to 81, I would have made a lot of, I cannot plot any point which is like 72.10. Do you understand? Very difficult for me to plot. So in this particular case, taking n as 80 makes sense.
Okay, yeah. Good. I think we did like that at school as well. So yeah, that's all right then.
That's good.
Yeah.
For a graph, this is a better value to consider.
All right. Okay.
Okay,
so, yeah, that was a great lesson. Thank you so much, sir. It really made a lot of sense. Thank you for going back to the basics and like explaining it from the start really clearly. Yeah, that was really good. So thank you.
Yeah, in the next lesson, we'll take box and whisker diagrams, and we'll go further into these things, and then we'll close this up, right? But in case you have any difficulties, share with me the questions. And as I said, there are many questions to be answered by your teacher also. You need to discuss with your teacher about few fine points so that you don't miss any marks in the test. Okay, that's kind of very clear.
Yeah.
Okay, then. All the best, Anil.
Will do. Thank you so much, sir. Have a good week. Yeah. See ya.
Thank you.
Bye.